Hello there, I am Mehmet Alkush. In this video, we will solve one problem in Chapter 7. A 6 kg block, which is initially held at rest, is released and slides down a frictionless incline, making an angle O 40 degrees with the horizontal. The magnitude of the horizontal force F is 8 newtons. A. Draw a free body diagram for the block. First of all, we choose an appropriate coordinate axis. Next, we represent the block by a big dot. Now we draw all the forces acting on the body. The gravitational force acting on the object is drawn like this. Secondly, since there is a contact with the surface, we draw the normal force perpendicular to the surface like this. Finally, we draw the horizontal force F like this. As the final step to draw the free body diagram, we can show the displacement vector d like this. Okay, that's all about the free body diagram. B. Find the work done by each force when the block slides 2 meters measured along the incline. The work done by the gravitational force is equal to m times g dot d. Since the angle between the gravitational force and the distance d is 90 degrees minus theta, then we can write m times g times d times cosine 90 degrees minus theta. If we substitute the corresponding numerical values into this equation, we obtain 75.592 joules. The work done by the gravitational force is approximately 75.6 joules. And the work done by the normal force on the block is 0, since the normal force is perpendicular to the distance. Finally, the work done by force F is F dot d, and since the angle between the vectors F and D is 180 degrees minus theta, with the numerical values, we obtain negative 12.257 joules, or approximately negative 12.3 joules in 3 significant figures. Okay, these are the works done by each force. As a conclusion, we can say that work can be negative, positive, and also 0. See, what is the speed of the block after it has slid 2 meters? From the kinetic energy work theorem, we have total work equals delta K, where delta K is the change in the kinetic energy. Here, since the initial speed is 0, then the initial kinetic energy is 0. Therefore, we obtain W total equals 1 over 2 times m times v squared. From this equation, we can have an expression for the speed. Here, W total is Wg plus Wm plus Wf. With the corresponding numerical values, we obtain the speed of the block after it has slid 2 meters as approximately 4.59 meters per second. The same result can be also obtained by a simple application of Newton's second law. However, as most of the students prefer, this problem cannot be solved using the conservation of mechanical energy. If you try to solve the problem by this method, you would obtain a different result. Okay, that's all about this problem. Thank you for your attention. See you in the next video.